Bright Field Microscopy, Part 2. I'm Dr. Sumati Hajela, Associate Professor, Department of Biotechnology, IPS Academy, Indore. This is my second lecture on this topic. In the first part, I have told you about the principle and various parts of bright field microscope. Now, what is the operating procedure of bright field microscope? You can read along with me that first of all, we will grasp the microscope arm with one hand and place your other hand under the base. What does it mean? That never hold microscope with single hand. We have to use both hands, one on the arm and other at the bottom of the base. Place the microscope on a bench, adjust seat. You need to sit properly at the correct position so that you can see microscope. So both things must be set before you start seeing through microscope. You have to prepare one slide which is either stained beforehand or it is the section or the substance whatever you are going to see is already colored. So uh, a thing which has a clear contrast must be present on the slide. Then uh, before keeping that slide on the microscope, you must clean the lenses and turn the coarse adjustment knob to raise the body tube. Revolve the nose piece to set low power objective lens. So initially things are seen through low power objective lens. Gradually, once it is focused, then we change the objective lenses. During initial stages, the condenser is kept up to the level of stage of microscope. The diaphragm aperture of the condenser is completely opened and the optical axis is focused by tilting the mirror. Then the image of the specimen is observed with a sharp focus using coarse control of the objective. When we place a slide on the stage, we must use the stage clips to secure the slide and it is not moving from its place from time to time. So it should be kept in its place. Initially, light should be at low intensity and gradually we need to increase the intensity of the light. Turn the coarse adjustment knob to lower the body tube until the low power objective reaches its lowest point. So you can see here this is the lowest power objective and it is brought very close to specimen. And after that it will not move. This is the lowest point till when it can come here. Looking through the eyepiece, very slowly move the coarse adjustment knob until the specimen comes into focus. Adjust distance between eyepiece. The position of the condenser is adjusted to improve illumination now and aperture diaphragm so as to get sharp contrast and best picture of the specimen. After adjusting position of condenser, good illumination is set and fine adjustment knob is used to further increase the clarity of the image. Observations are recorded and diagram of the object is drawn by viewing its image under microscope. Switch to the high power objective lens only after adjusting condenser and iris diaphragm, as I told you before. For oil immersion viewing, place a drop of oil, which is mostly cedar wood oil of 1.5 refractive index, is dropped on the specimen, and uh, then immersion objective is lowered to the point that it lens is dipped in that oil. You can see here it is written that lower the objective until oil makes contact with the objective. Looking through the eyepiece very slowly, focus the objective away from the slide by raising the objective lens. So what does this mean? That keep it very low and then make a distance from the specimen, and this will give a correct focus. And the way we should be looking the slide or specimen, you can see that we should move stage in this direction, then here, then here, and then here. This is how we cover the entire field which is coming under the microscope. Now, causes of error in focusing. Revolving nose piece is off center. Preparation is upside down. Thick cover slip has been used. Dirt or dried oil over the lenses. So it is very, very much important that we clean lens after use. Air bubble in immersion oil. Poor illumination, condenser not fully wrapped up. So these are the various reasons which give trouble shooting. Now, what are the uses and applications of microscope? Bright field microscopy. Compound microscopes are necessary for viewing and examining the small organisms like bacteria. It can be used to determine the shape of cell and organelles. It is best suited for colored or stained microorganisms and fixed tissue sections, and unless useless for living bacteria, non-photosynthetic protists or metazoans, or unstained bacteria or tissue sections. Most routine medical microscopic observations of blood and tissue are done using this microscope. This microscope is adaptable to new technologies like molecular imaging and cell imaging. What is molecular imaging? It is time and space related dynamics of molecules. And cell imaging is identifying small molecules within the cells like proteins and RNA. There are limitations also while we use this bright field microscope, which are objects which give poor intensity contrast in transmitted light rays cannot be resolved properly. Staining techniques enhance the light absorbing capacity of object. However, smaller objects like cellular organelles can't be resolved satisfactorily even after staining. This type of microscope has this limitation also. that organelles are not properly resolved. Furthermore, staining kills the cells and so live specimen cannot be viewed. This is most important, that we cannot see live cells under bright field microscope. There are precautions also, like always carry the microscope with both hands. One hand should support the bottom and other should have a firm grip on the arm. I will advise you not to move microscopes too much. So in labs, they are kept at a proper place with well lighted, in a well lighted area. Otherwise, it has a built-in light system. So there should be no need to move microscope many times. Be sure to carry microscope high enough so that it does not bump against anything. Okay, in the lab, you will find many things, uh, desk and tables, stools and fridge, and there are many things. So handling must be proper. If you are moving it, if the microscope uses a mirror, one should never use direct sunlight to light the or illuminate a specimen, as it can cause severe damage to your eye. Direct sunlight should not fall on it. Diffuse sunlight should fall on the mirror, though it should be bright enough to view your specimen. When artificial light source is used, it is good. It's a good practice to shut off the light when not in use. This will save energy, protect the specimen, improve the longevity of instrument, and also keep the light from getting too hot to touch. Lenses are very delicate and shouldn't be touched directly to prevent smudges, scratches, or breakages. So lenses should be cleaned with care, with soft cotton cloth. Microscope should be cleaned properly after every use and covered with cloth to prevent the entry of dust. If there is dust or some grease on the lens, then you cannot see your specimen properly. So these were the all precautions as well as limitations and applications which we get from microscope. And with this, my this lesson is finished. These are the, you are seeing the references. These are few references or sources from where I have taken material to teach you. And again, this is not for public use because uh, figures and certain slides I have not made myself, and this is only for viewing by my students only. Thank you.